Good evening, everyone. Welcome to day 4 of Avalon project. So yesterday we talked about um, the breakdown of backend events and uh, actions and events. Today we can dive a little bit deeper into the technical side of this. We're going to talk about we're going to talk about how and where are we going to host our backend service, have more details about what the backend does, and break down the structure of events and how are we going to store the data. So, as we mentioned from the very beginning, we want this to be a web application. It must be accessible via the internet from anywhere on any device. So we decided it is likely to be a web page backed by a backend hosted on the cloud. So there are several major cloud service providers: AWS, Microsoft, Google, IBM, Oracle, and Cloudflare, and many other smaller ones. These are the major players. Um, there are much debate, and some even claim that Microsoft has the biggest um, cloud service share, though I am very skeptical about how did they reach to this conclusion. But well, this is, let's call it my opinion, that AWS is the de facto cloud service provider in the industry. So when we talk about cloud services, we almost immediately think about AWS, which is fair because they offer the most services and the most reliable services and almost the cheapest prices. And the resource about AWS is just much more than all the other cloud service providers. There's a bigger community. So in our project, so I'm gonna mention about this later, but comparing cloud service providers is too big of a scope for our series. And to make this series more compatible with the working environment, so we're gonna just use AWS, though this is against what I recommended, which is to always consider alternatives. But let's just to keep this series about technology instead of too much of finance or strategic planning. So we're going to only consider AWS. But again, I'd like to remind everyone that it is always a great idea during technical interviews to mention there are other cloud service providers, and to really think about, to at least have this mind that it doesn't have to go on AWS. Also, there's a debate, especially in more conservative industries like banking. They would love to be able to to develop their application platform or provider agnostic. And there are tools for that. Okay, the name just I can't remember the name on top of my head, but there's was it no, CloudFormation was AWS. What was the other one? Anyways, so there are this universal more universal templating tool to be able to interact with the different cloud service providers. And from what I know, banks do try really hard to be able to run their applications on multiple platforms so that first they don't get tied into one single service provider, and second, when one goes down, they could always have a backup. But this is a very costly approach because let's face it, we're only going to host all our stuff on one platform for the majority of the time. And disaster recovery and dealing with edge cases, it's always a very expensive operation and provide very, I wouldn't say provide very little value, but it is very hard to measure. So I'm just throwing this out there. There are more cloud service providers than just one, and it is possible to host your application on different cloud platforms. And actually, that's something people actually do to choose the cheapest service from a provider against the other. But in personal projects, let's just keep it simple. It doesn't. We don't have to do that. And during the technical interviews, it's always good to mention, but eventually we're going to come back and focus on just one single cloud service provider. Okay, with that being said, let's dive deep into the design. So, as I mentioned, it's always well, even though we have settled on AWS, but still we're gonna have to think about how are we gonna host our backend. So in AWS there are many different services, but fundamentally they are divided. We can categorize them into two categories. First is Lambda, which is a short-lived, fully managed, just a function to be run on the cloud. The second is the EC2. Many other services are based on EC2, so we'll just call it EC2, which is you basically rent out an instance, most likely a virtual machine from AWS, and you have full access and control over this instance. The major difference for our use case is that Lambda is pay per use while EC2 is pay per hour. Think really hard about what we're going to do here. We're going to do a pet project. We're going to deploy it for our friends to use. We do not want to pay when we don't use it. And frankly speaking, we don't even want to pay when we do use it. Gladly, AWS does come with this free tier, which can basically let us do whatever we want within a reasonable margin without even having to pay. So considering this, EC2 is out of the picture. We're gonna go with the Lambda because it's much cheaper. So again, this is I'm gonna pause a little bit and talk about cost. So even though Lambda is pay per use, and if you look at the free tier, it looks amazing. But when you have actually a service in the production environment with paying customers, oftentimes it is not necessarily cheaper than EC2. Even though it comes with many proclaimed benefits. For example, it is very quickly scaled to handle the spikes. It is fully managed so that it's very much secure and everything. But I want to remind everybody that Lambda Lambda or EC2, they do not necessarily cheaper one than another. It all depends on your use case. So don't jump right into okay, we're going to use Lambda or we're going to use EC2. Definitely think about your use case and have a good reason about it. So my reason for going with Lambda is that it's highly unlikely we're going to have more than ballpark of 5,000 requests per month. If we were have 5,000 requests, we're doing some serious gaming. So in this case, it's not worth. So it's way below the free tier of AWS provides for Lambda function invocation. So it's basically a free service. While EC2, at least I'm gonna have to pay $7 a month. So I'm gonna go with Lambda, and that's my reason to save $7 a month. And the go-to database again. During technical interviews, we are often asked about relational database versus NoSQL. This is a very huge topic, but gladly in our case, if we think about it, there's not that much of a relation to be considered. We're just going one event or one action after another. So DynamoDB as a key value database is good enough for us. We don't really need ACID. We don't need the transactions. So, and most importantly, it is also pay per use. So we and all the other database provided by AWS, including RDS, Aurora, even though DocumentDB, which is based on MongoDB, they are all pay per hour or pay per instance. So in this case, to save some money, to have a free project per se, we are going to use Lambda plus DynamoDB. And this basically means that we're going to have an event-driven application because Lambda is short-living. We can't really afford to, or it is practically impossible to have an instance running forever, which plus the limitation of DynamoDB, it is easier or so event-driven design is event-driven application is almost the only option. I'm a little bit lazy to list all the other options here. Again, do as I say, not as I do. But let's save some time, not expand too much on this. And for the backend, as I mentioned yesterday, we are going to have a mix of RESTful API and WebSocket. The RESTful API is mostly for game admin to create games for users to join. Once the players joined, they're going to establish a WebSocket connection with the backend, and all the communication will be done there. Based on the list of actions I listed yesterday, I came up with a list of WebSocket events which will be saved in the database. And if we look at this, at any event, at any time, a player could rejoin the team, just fetch all the existing events from a game and know the latest status of the game. Okay. There is something, so there is this edge case I can think of right now, which is what if we are what if we are in the middle of round of votes? So, for example, the backend sends everybody a request to vote for a team proposal of a round. And a player's browser crashed, and they just reconnect to the backend to reestablish the WebSocket endpoint. So I think we'll have to add one more RESTful endpoint, which is to fetch all the events from the backend, and all the broadcast event will be also saved in the database, so that when the front end sees a request event, they'll load properly. So I'll update the design doc later. And then let's take a look at the data models. So we're gonna so keep in mind that DynamoDB is a key value pair database, which means we have to identify so everything is saved in one big table, and all the data is differentiated by the primary key, which I call it game ID here, and the sort key. So what you can think is what you can think about this is it's basically a map, or it's a map if you're using Java, or dictionary if you're using Python. So the primary key and sort key, the combination of the two is basically the key of a dictionary or a map, and everything else is just its value. So that's why you'll see some weird SK ID structure. Okay, let's take a look at the game. I'll explain it later. So the primary key of the game model, or it's basically a row in a huge table. The primary key, of course, is the game ID. The sort key ID, the sort key. Yeah, the official name is the sort key. Is just going to be a string game. So what we have here is, if we do a query in the DynamoDB, we're just gonna say that, okay, give me the entry with the game ID of the given game ID, and the sort key is the word game, and by this we are going to be able to fetch one and only this one entry, because game ID must be unique. And so the combination of the primary key and sort key must be unique. So since the game ID is an UUID, and we do not, with the same UUID, we do not have any other sort key using the string game, so we're able to fetch this one and only event, one and only entry. So let's take a look at the player. So we have game, we have row, we have known players. We have another field called secret using UUID because it's not gonna make the application much secure, because, well, after all, we're not gonna focus too much on security, at least for at this stage of development. We should, but this game, we're not, it's not high stake, it's just among friends, so we don't consider security that much. But the reason why I added the secret here is because the player ID is going to be shared everywhere. To avoid accidentally we're gonna making the request using the wrong ID. I'm gonna send the secret to each player the first time they establish a connection, and for anything for and this secret is for them only. For any event they submit to the backend, they'll have to provide a secret and will be checked against the database, just in case other players, in case we have a bug in the application, to basically send an event on behalf of a different player. So as you can see, the sort key we're using, player underscore player ID. This is going to be another UID we generate. So the reason why we put the sort key like this is because there is this concept of query and there's this concept of scan in DynamoDB. What a query does is that it indexes the primary key and sort key, so that it goes the index first, then fetches the actual entry. It is much cheaper. It is much faster. While a scan is the database going through every single entry of the database to find the necessary to find the entry matches the query, which is much more expensive and much slower. So we're going to try to use query as much as possible, which is a good practice everywhere. But for queries, again, the primary key, they must be exact match, and for the sort key, it provides some arithmetic comparison, like equals to, not equals to, greater than, greater or equal than, less than, less or equal than, and there's and there's between. For string comparison, it only has one option, which is begin with. So for us to be able to query other entries we'll have to make sure that each entry has a unique prefix, so that it can be easily found. Like, let's say, well, in this case, for example, if we know the game ID, we could make a query that, okay, give me all the entries with the primary key of this game ID, and sort key starts with player underscore. Then in this case, we'll be able to fetch all the players in this all the players in this game. And there's it. So same thing with mission. So when we query missions, we're just going to go with, okay, give me all the entries with this particular game ID, and the sort key starts with mission underscore. And when we fetch all the missions, we're gonna have the mission number, and so that it can be sorted. And as for mission vote, when we want to find all the votes of a particular mission, we could always go with okay, the game ID is this one, and the sort key starts with MV mission vote. Actually, we don't really need a mission here. Same as round. So So the round, the sort of key of a round model or round entry is a little bit different from mission because um, we have 5 missions and each mission can have up to 5 rounds. Um, so if we're gonna just use numbers to differentiate, without a mission number, we don't really know which like without this mission number, for example, round three, okay, round three of which mission, we don't really know. And plus, when we are looking for rounds, we always just um, go with a particular mission. So in this case, if we want to find all the rounds of mission 3, we can go with a query which the primary key equals to the game ID and the sort key starts with round underscore 2 underscore. Then we'll have all the rounds of mission 2. Um, so yeah. And for mission vote, of course, it follows the same pattern as the round. We have the mission number, we have the round number, and same as assassination. Okay, so I think it's almost 30 minutes. I'm gonna take a pause here. So I think what I will do is what we need is one more model named event, and so that one more data model, one more event data model, and one more endpoint get game events. Do we get game events? We'll have to fetch all the events for a particular player. For example, we don't really want the say for example the role to be known by everybody. Um, so yeah, get event the get event results for each player is different, so we'll have to pass in some kind of identification. I'll think about it and update it and update it on GitHub as well. Okay, let's do a recap. So today I think we are mainly talk about technology, technical details, but I think the lesson learned today is that we always want, just like other technical just like any other parts of technical design, when it comes to the cloud service providers and their services, it's always great to compare different options and find the optimal solution suiting the use case. I cannot stress this enough, how big of a red flag is to an interviewer that the interviewee simply goes with one solution without even thinking about it. It really shows lack of experience, lack of knowledge, and frankly speaking, it's just lacks of the core of a software engineer needs. Cool. So I'll update the document later today, and tomorrow I think we can start design a state machine for the WebSocket events. Yeah, I'm pretty excited. Maybe we'll get to write some code tomorrow. Yay! Um, okay. Nice talking to you, everyone. See you next time. Bye.